Alright, it's time. You and I have been talking about atoms, the building blocks of everything around us right throughout this subject so far. It's time to put some detail to these atoms. It's time to talk quite a bit more about them. I've got a picture of an atom here for you. Atoms are made up of 3 subatomic particles that we're going to talk about quite a lot throughout this entire subject. Those 3 subatomic particles are protons, neutrons, and electrons. Before we assemble our own atom though, I thought it'd be interesting to take a trip down memory lane and have a look at how this model of the atom came into being. People came up with some really clever and interesting ideas in order to be able to discover all of this information that we know about the atom today. When you think about the fact that they're so small and that we cannot see them, that really is a truly incredible achievement. So, the idea of the atom has actually been around for hundreds of years, but it wasn't until 1808 that John Dalton actually put some sort of more concrete ideas to it. He postulated that the world and all of the matter around us was made up of small building blocks called atoms. He went one step further than that and said that the materials that we work with, the compounds, must be made of atoms that were joined together in a fixed and specific ratio. All of that information is very sound and actually still holds up today. But it was quite some time, the best part of a century after that, before we really started finding out about the different pieces that make up the atom. So it wasn't until the 1890s, much later in the century, that J.J. Thomson made the next big leap in terms of the structure of the atom. He was investigating with the nature of electromagnetic radiation, and in doing so he discovered the presence of electrons in atoms. Electrons are a small subatomic particle with a negative charge, and they are of great interest to us. So this discovery was made, as I said, in the late 1890s. Shortly after that, it was decided or recognized that all of the matter around us tends to be neutral overall, that it has no charge. So if we have these negatively charged electrons, there must be something positively charged to go with it. And this led to J.J. Thomson's affectionately named plum pudding model of the atom. Our plum pudding model consists of those negatively charged electrons being spread throughout the pudding, like the little plums and pieces of fruit, and the pudding itself is a positive sphere of diffuse positive charge. So this is our plum pudding model of the atom. This is what the atom was believed to look like for some time. Then, early in the 20th century, Ernest Rutherford was working with a team of scientists doing some experiments, and he was projecting small positively charged particles at pieces of gold foil. And if we get into our minds the picture of this plum pudding model, there were some expectations about what would be produced here. So he would fire a small positively charged particle at the atom, and no great surprise, because most of it is just diffuse positive charge, it would pass through. And another one would pass through, and another one would not pass through. What they found was that some of these small positively charged particles wouldn't simply pass through. They'd be deflected off to either side, or even in some cases bounce straight back. This was remarkable, this was really surprising. To use the words of the time, they said it was like taking a shotgun, firing it at a piece of tissue paper, and then having the bullets bounce back and hit you. It was completely unexpected. So this led to the idea that the atom must have some central mass, something in the middle of it. So Ernest Rutherford's work, in conjunction with others like Niels Bohr, who did quite a bit of study on the nature of electrons and how they are present in the atom, led to a more modern model of the atom, where we have a central positively charged nucleus for our atom, and here we have protons, protons being positively charged subatomic particles. Then, orbiting around the outside of that positively charged nucleus, we had the negatively charged electrons. And this was the model of the atom that stood up for quite some time. It wasn't until substantially later, until 1932, that James Chadwick discovered the third and final subatomic particle. He did this while exploring discrepancies in the masses of different atoms. Things didn't quite line up, something was missing, and his deductions led him to the discovery of the third subatomic particle. These are called neutrons, and as the name implies, they have no overall charge. They only contribute to the mass. So, by and large, that leads us to our model of the atom, to what we have now. We have positively charged protons, neutral neutrons, and negatively charged electrons. So, with all of that history behind us, let's now take a close look at exactly how we put together an atom. First of all, we have in this diagram in red, I have my positively charged protons, And they're mixed in green with my neutral neutrons, and they are in what we call the nucleus. That's the center of the atom. So again, those red subatomic particles, they are the protons with a positive charge. The green ones, they are neutral with no charge, and they make up our nucleus. Then, orbiting around the outside of the atom, we have our negatively charged electrons, and they exist in what we refer to as an electron cloud. Electrons are quite tricky creatures. Their nature is challenging, shall we say. So the electron cloud, we do sometimes more specifically say they reside in orbitals, or much more generically, we say that the electrons orbit around the nucleus in shells. And that's the terminology that you and I are going to focus on today. Shells are nice and easy for us to visualize. Now, when we are talking about our model of the atom, we're often interested in particular regions. So we're often interested in the nucleus, where the protons and neutrons are, but we also often go out of our way to describe the electrons. When we refer to the electrons, there are a couple of different regions we look at. All of the electrons that are in close to the center of the atom, or even in the sort of central area of the atom, we call them the inner electrons, but quite often you and I are really interested in the ones furthest away from the nucleus, the ones in the shell furthest away from the center. We call these the outer electrons, or their technical name, they are the valence electrons. You and I are going to talk about them all the time throughout this course. Those valence electrons are of primary importance to us in this subject. They often dictate the chemistry and the behavior of different atoms, of different elements. So they will be really important for us. Now, the other thing we can start discussing about the atom is their size. We know about the atoms, we know they're really small building blocks. With our power of scientific notation, we can start putting some numbers to that. I keep saying that atoms are really, really small. How small? These protons and neutrons in the nucleus. Each of those protons or neutrons weighs about 1.7 by 10 to the minus 24 grams. That's about a millionth of a millionth of a millionth of a millionth of a gram. So those protons and neutrons, really small mass. The electrons, even smaller, almost 2,000 times lighter. So the components that make up the atom are very, very small. Most of the mass of an atom is inside the nucleus with the protons and neutrons, but most of the volume of an atom is actually taken up by the electron cloud. Literally speaking, most of an atom is actually empty space. Very little of it is made of material. In fact, if I try and put that in perspective for you, if I was to take an atom and say I have a nucleus the size of my fist, the nearest electron is several hundred meters away from us. So it really is almost entirely open space. And yet that's what our atoms look like. So if these building blocks are really, really small, that means that to make any everyday object, like a pen, we need an awful lot of them. In an object like this, there are something like 10 to the 24 atoms, or a million, 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 million atoms, all just inside a simple pen. You want to take something a little closer to home? If you take the average person, they contain about 6.7 by 10 to the 27 atoms. That's about 7 billion atoms. If you start thinking about rooms or buildings or countries, the number of atoms involved is phenomenal. Massive, massive numbers of them. Right, big topic for us today. So what have we discussed? Had a bit of fun. We looked at the history of the atom and how some pretty clever people came up with interesting and intuitive ways of finding out exactly what an atom looks like. We decided that they are made of a nucleus where we contain our positively charged protons and our neutral neutrons, and then orbiting around the outside in shells we have our negatively charged electrons. That is our model of the atom that we're going to work on. We then went on just to emphasize the fact that they are really, really small.